So it's sort of like two topics in one. And yes, it's our final test, I guess, that you're going to have. So counting and stats. There's not a lot of counting that you actually have to do in year 11 and year 12. In year 11, yes, there is. In year 12, not so much. It's sort of already given to you. And this is the situation. But it leads you into, and sometimes you never know, there might be a little bit, especially in the discrete stuff. So we are going to look at, think, what on earth is this thing called counting? It's the number of ways that things can be arranged, or the number of ways that you can get to do certain things. What am I looking for? I'm looking for my book. If you looked on the program, we're not actually going to look at, so sorry, here's our program. 8D, BC, hopefully we're getting, it says 5 weeks. Exams are in week 7. So let's try and cruise our way through. There's not a lot of algebra in this. It's very much calculator stuff or just diagrams and by itself, simple multiplication, quite frankly. General maths, they sometimes do some questions like this where they go a bit crazy and they're looking at networks. But you can have a look with these ones. So we've got town A, B and C, and they're connected. It could be roads, it could be railway, who knows. And you want to know how many different ways to get from A to C. Now, one of the ways that we can do is obviously list them all out. If they had different labels, I guess, but you could see the top one and then go that one, yes? You could go the top and then go the second, the first and then the third, first and then the fourth, and so on. And you could just count them and list them and then count how many there are. But hopefully you can come up with a system. And it works every time when you go, well, if we multiply how many options we've got to go from the first to the second, and then multiply that by how many you've got to go from the second to the third, you will actually get the number of paths that you've got happening there. You need to sign in. Okay, so we're sort of going to go, yeah, I think we can sort of go 3 times 4 times 3 and do that multiplication. Are you happy with that? So we're just going to go straight to what happens now when we're looking at, I mean, that's the same sort of thing. Do we really want to do that? No. We want to focus on permutations and combinations. All right? A permutation is a group of symbols in any arrangement of those symbols in a definite order. So we've got, if we have a look at, let's just take X, Y, Z. If we're looking at 3 at a time, so this would be over here, sorry, that we're going to be talking about, as we said, are permutations and combinations. We want to know what's the difference. So you can read those definitions. Basically, permutation, the order is going to matter. Combinations, we don't care. The order doesn't bother us, right? So with a combination, X, Y, Z will be the same. It'll be considered the same as Y, X, Z. Y, Z, X, all the same. Whereas with permutations, right, we're going to say, well, how many different ways can we put them? Can we arrange them, right? The arrangement is that key word. So you can arrange them to be, yes, X, Y, Z. Can you come up with another arrangement? Yes, I love that you are being systematic. X, Z, Y. Another arrangement. Y, X, Z. So you're just mixing those around. And now, of course, we could then say, well, that would be Y, Z, X. Agreed? Can you come up with another one? So we've got X first, Y first, Y first, Z first, X, Y, and then, of course, Z, Y, X. It's pretty easy to organise how many ways that you could arrange it. I always like to think of the boxes, because it's not just going to be 3 things. So what happens if there are 8 teams in the AFL top? How many different ways can we arrange the top 8? Are you going to list all the different ways that 8 teams can be arranged. You don't want to do that. And then you're thinking, oh my God, what if I missed an order? It's just crazy. So notice when we do this, how many choices have we got for the first position? 3. It could be X, it could be Y, it could be Z. Now we've used one of them. So how many choices have we got for the next one? 2 and then 1. And so this means, like we skipped the first bit, but this is when we times them together. So 3 times 2 times 1, and we get 6, which is the number that we came up with just by listing. And we could trial this and test it, and come up with a conjecture like you did with your investigation. But we'll be spending hours just writing out all of these combinations and going, oh, you missed one. Oh, no, you didn't write this one. So just trust us here that will actually work. And not wanting to ruin the surprise for the second little part of this, but we've mentioned to the specky people about this thing called Factorial. And you might have seen when we flashed it up there, this exclamation mark. So when we have n factorial, who would like to specky volunteer? Yes? Where would you like the mic? Oh, doesn't want the mic. Then I'm running back. I'll repeat what you say. Yes?
The multiplication of all the numbers.
The multiplication of all the numbers leading up to. So pretty simply, yep, something like 7 factorial. That would just be 7 times 6 times 5 times 4 times 3 times 2 times 1. Easy? Hey? Pardon? No, it's a new thing for us. Oh, well, it's all right. It's just coming. So you'll see it's coming in a type of thing. Now, how you can write that and just some of the little tricks that we've got. So n factorial, that would be the same as n times what? Yes, n minus 1 factorial. And if you're ever stuck with that, right, go back and have a look at the real numbers, right? So you're having a look here and you're going, well, if I just take that 7 out and I'm then left with all of this, well, isn't 6 times 5 times 4 times 3 times 2 times 1, isn't that 6 factorial? Have you signed in, dear? Yeah? So just little things to consider, because that's what we're going to be doing, really. So if I was talking about our 8 teams in the AFL, and we said how many different ways can we organise those? Well, it would just be 8 times 7 times 6. I had to think then. So 6 times 5 times 4 times. So instead of writing all of that out, long-winded, wouldn't you rather just write 8 factorial? So it's just a shortcut. We can find it on our calculator. Let's try that. Your factorial button on your calculator. We go option. No, we want more. This is sort of, it's not in the, might be in stat, who knows. But if we go more and you go probability, and you have here's your exclamation mark, so we can go, ta-da! Oops, you better go. Let's go 5 factorial. So that's 5 times 4 times 3 times 2 times 1, and you get a reasonably large number. Okay? So just remember your option button on your calculator shows you a wealth of values there. So the first little section, they're really going to make you focus on just doing the little blocks. But if you ever see that it ends up being like this part B, 5 times 4 times 3 times 2, yes, you could do that. I mean, obviously, if you times by 1, that's the same as 5 factorial. I think that's okay to write 5 factorial or 120. It's up to you. Technically, if you're doing the boxes, you don't put a 5th box, but we'll have a look. So if we're looking here, we've got how many permutations are there on symbols A, B, C, D, E if we take 2 at a time. In other words, you've got 2 positions. Does that make sense? So like we said before, how many choices have we got for that first position? Well, we've got 5 letters to choose from, so 5. How many have we got to choose from the 4th position, for the second position? 4. And Saskia coming in and going, oh my God, are we seriously doing this? This seems so simple after calculus. Yes. So it's a bit of put your feet up. relax a little bit and don't strain your brain so much. Finishing off with nice. Is that okay? Oops. Don't know what happened there. Oh, I pressed the video, obviously. Okay. So are we happy to dive in? Shall we do the first ones? Oh, let's not even bother with the first one. List the permutations on the symbol A and B, taken one at a time. How rude. Well, you could have A. Or you could have, oh, what a surprise, B. 2 choices. And if you take them 2 at a time, did you just do that to me? I think you did. Right, 2 at a time. And again, you could have AB or you could have BA. You're either thinking about that going, oh yeah, I'm listing them, or you're doing the little boxes because you've got 2 and you're saying, well, I could have 2 choices for box for the first position and so on and so forth. List the permutations on the symbol of W, X, Y, Z. Shall we do it? Yes? Let's do it. You might go, this can't be this simple, so it makes it difficult, but it's not really. So list the permutations on the symbols W, X, Y, Z, taken one at a time. So we've just got, think about it, if you're finding it difficult, we've just got 1 box to fill. So how many choices have we got to fill that 1 box? Did someone say 5? Okay, I just thought I heard. How many ways if we take 2 at a time? So then we've got our 2 boxes. So how many choices have we got for the first position? Feel like we're doing ballet. First position, 1, 2, 3, 4. Now we've used 1. So 3, so we can go 4 times 3. Make sure that you read your questions carefully, because how could this now change? If it just said how many ways can we have this if the letters could be repeated, would that change anything? Yeah, because then it would be 16, 4 times 4, because you can use that letter again. But with a permutation, it's the different arrangement. So once we've used 1, it's used. So does that make sense? Do we have to do the rest of it? No. Well, I'll give you 5 seconds. You do that. Okay, so we're going off to an example, and now we're starting to put a couple of restrictions in there. We're going, well, we need this, or we have to have this, or whatever. So if we look at the first one, that's what we've just been doing. There are no restrictions. So we can go with our boxies. How many are we choosing? 3 digits. So we're going to have the 3 boxes. And there are no restrictions, so how many numbers have we got to choose from? So 5 times 4 times 3. Are we happy with that? Yeah? All right. What about B? What's going on? Oh, come on, board. I love you. What's happening with B? Still 3 digits. The number must be greater than 500. So what's happening there? Yeah, you've got a restriction on the first 2 digits that you can, the first digit here that you can choose from. So if it's got to be greater than 500, then as Karen said, you can only use the 6 and the 9. So you've now only got a choice of 2. You did it again. Time of day, he keeps giving me the finger, the bird. 2. Right? So now, how many for the second position? Yep, because you've used one of them. Doesn't matter if you've used the 6 or the 9, one of them's gone. So you've now got 4 to choose from. Then you choose one of those, you've now got 3 left to choose from. Does that make sense? So it's a bit logical. Did I say illogical? I meant to say logical. Okay, have a look at C again. Try not to look at the solutions. I'm seeing some of you looking at your books. Sneaky sneaks. All right, so with this one, the first and the last digits must be even. So what do we have to do then? What can we choose for the first and the last? Let's start with you could start with the first or the last, doesn't really matter, but let's start with the first. How many even numbers have we got to choose from? 2, right? Again, 2 and 6. So we've chosen that, which means how many have we got to choose for the last one? 1. Doesn't matter if you went the other way. Clearly not. If you went with, well, how many have I got for the last one? 2. And then you'd have 1. 2 times 1 is the same as 1 times 2. So it doesn't matter. And then how many have we got to choose for the middle? 3. Yeah? I think it makes it really easy if you do the boxes. And you ask yourself, well, how many options have I got to do this? Oh, you frown at me, bro. It's why. Sorry, what's the question? Oh, okay. They don't want to share with me. That's all right. So they're not too bad. We'll go through and then we'll look at the factorials where we're just fooling around a bit with some of the algebra with that. It's quite nice. To your notes page, or you could even copy this in your OneNote, whatever. But this, where does this come from? From your outline, right? From SACE. If we have a look, what does it mean? So this might have been a little bit of a pain in the butt for you to go 26 times 25 times 24 and so on, was it? Did you do it? Did you do it? Yeah, good. Okay, so that is the same as doing this. So this would be the same as P, 26. How many were we choosing? 15. Okay? So when we talked about factorials, you're looking very tired, Tom. When we're talking about factorials, that means it's 26 factorial, which is 26 times 25 times all the way down to 1, over n take, all right, I'm following this, n take r, so 16 take, thank you, 15 factorial, and you go, great, that gives you, it's going to come back to this, right? Still irritating to times it all in your calculator. Can we grab our calculators, please? Can you remember how to get back to your factorial button? Right, so just if you didn't, we're going to go option, more, probability. Look what's next to the probability, the factorial button. Yes. So if we now go 26 and then press that button, so you get your P. And how many will we choosing from the 26? 15. You should get the same answer for when you did 26 times 25 times 24 all the way down to 12. So shortcut, technology. Write yourself a note. And while we're here, can you see what's to the right of it? So when we do combinations, that's going to come up shortly. So keep going, see how it goes. We're just going to look at factorials to finish off, and we'll probably do combinations tomorrow. So go back and have a look at this. You're basically choosing, right? You are choosing 3 from 1, 2, 3, 4, 5, 6, right? How many arrangements of 3 can we get from 6 different letters? Karen, we're listening. So how many arrangements of 3 can we get from 6? Now you can do the 3 boxes and do times, which is great, but I want you to check with your technology. Check when you go P6, 3. Do you get the same answer? So try and mix it up. A little bit of writing with the P, doing with the boxes.